Hi everyone! For this week's tutorial we got a tie on your votes. The themes particle and geometry deformation got the same vote number, so I had to think an interesting and funny way to have particles deforming a geometry. I came up with this idea for generative art, where we have particles controlling the Voronoi and edit our geometry pieces to look more into soft bodies. In the end, it looks like a generative soft bodies animation without soft bodies. Hope you enjoyed this one. Okay, let's start by placing our geonode. Let's call it generative Voronoi. Okay, let's dive in and let's place our box. Okay, so our box, let's give it a size of 10 by 1 by 10. Zoom out, see our little box. And let's place a Voronoi. Okay, it is asking for points. Okay, so let's scatter some points. And we have our basic Voronoi. Okay, pretty cool, pretty simple. Okay, so instead of scattering on our box, because in this way we are scattering on the surface, so we have on the bottom, on the top, on the sides. Okay, so instead of using the box, let's use a grid. Okay, let's scatter on the grid, and let's be sure that our box has always the same size as the grid. So let's copy parameter, this one. X, we want relative reference. Okay, let's copy paste. On our Z, we want to use Y. Okay, this is size Y because the grid works with only vector of 2 values, so it's X and Y. If you want, you can come here, copy parameter, and paste relative. The name is that. Okay, so if I change, you can see, let me wire the box. See the box. So if I change the values from our grid, box will update. Okay, pretty cool. So now we scatter our points on the grid, so they are all on the same plane on the floor. Okay, and now the Voronoi is a little bit different. Okay, you can see on the edge, on the sides, that it is a little bit different. Okay, so now let's move our points, and if we move our points, our Voronoi factor will change. So let me show you a quick way to change the global seed, and you can see that our Voronoi it is changing. Okay, so let's turn off relax operations. Let's leave it with relax. So let's move our scatter points with our PopNet. Okay, so we will have particle simulation controlling our deforming geometry. Okay, that is the main purpose of this tutorial. So let's dive into the inside PopNet. On our pop source, let's change to all points to use the scatter points. And on birth, we just want to emit on the first frame. Okay, so now it is emitting only on the first frame. Okay, so let's add some movement to our particles. So let's add a pop pop. Okay, let's add some turbulence to our movement. Okay, so let's use a flow noise. We always use a curl noise or turbulence, so let's use a different one now. Let's change this to 3D input 3D noise. We want output to be a noise with the vector of 3 values. Let's wire the position to the position and our noise to the velocity. Oops, sorry, to the velocity. Okay. Let's right click on our flow noise and change and do create input parameters. Okay, so we can control these parameters outside the VOP. Okay, so we have here our parameters. So if I go up and select our PopNet, we can see our particles moving. Pretty cool, right? Of course, you can add a little bit more force, like 2, and even decrease a little bit our frequency. So if you want to be sure what the particles are doing, you can place a trails. Okay, let's change the 150. Okay. And you can see a little bit better the movement of your particles. Right, pretty cool. So right now, if I rotate the camera, the viewport, you can see that our noise, it's 3D, right? It's going up, down, and to the sides. Okay, so we want to control this vertical movement. Okay, we don't want vertical movement. We want to have this noise on 2D. In other words, move on the floor. Okay, don't go up, neither go down. So on our pop fob, let's pick this vector and eliminate the y force. Okay, so let's use a constant. Okay, we did this on our very first PopNet tutorial, so if you want to go check that. So we want to keep the x, we want to keep the z, and we want to kill the force on y. Right, so let's multiply this vector by this vector. So anything, any force that is y on this flow noise, it will be multiplied by 0, and everything that is multiplied by 0 is 0, right? So our velocity will be always 0 on the y. So now if you can see our noise, it is on the floor and it is 2D noise. Okay, pretty cool. So it is moving on x and z. So now we have these points, right? These particle points from the PopNet, and they are wired to the Voronoi. So check this out. Now we have our Voronoi moving. Pretty cool. We have some organic movement on our Voronoi. That's cool. So now let's edit a little bit this Voronoi. I don't really like this visualization. Okay, so let's try and get closer to soft bodies like I did on my study. So let's use a for loop for it. So we have, oops. Why is not? Okay. We have a for each. Sorry, it's not a for loop. It's a for each named primitive. Okay. And this way we can control each individual segment. Okay, each individual factor. Okay, so if I wire this, you can see that now we are working this one. Okay, I think if I change, no, okay, I know there's a way to see a different piece, but that doesn't, we don't care about that. Okay, so I'm going to change the points, number of points. Okay, 50, so we have now less fractures, so we can be a little bit faster on our tutorial. Okay, so here we are going to smooth and turn a little bit to spheres these fractures. Okay, so let's go with the VDB from polygons. We are going to convert these to a VDB. Okay, so now we have a VDB. Let's increase a little bit the resolution. Okay, and now let's smooth SDF. Okay, so now we are smoothing. Maybe this is way too. Okay, maybe 2. And now we need to decrease it a little bit. Now let's go to 1 because I'm seeing this as really low resolution, and that will be bad when we go back to polygons. Let's go with this one, and smooth, let's increase to 4, 5, 4, and voxels 2. Can we use both numbers here? Let me see. No, we can't. Okay. So let's go 2 and 3. That's cool. That looks cool. Now let's convert these to polygons, back to polygons. Okay. Polygons. Very cool. Now if we see the final result, you can see it looks like soft bodies. That's pretty cool, right? Really smooth boulders. Okay, and now they are moving with the simulation that we saw previously. Okay, you can see now it is getting a little bit heavier, the system, because we are converting to VDBs, then smooth, and converting back to polygons. We could try and use only the subdivide, okay, instead of converting everything to volume stock, but you can see that that's not really cool. Looks more not so smooth if you could, like if you convert to VDB smooth as a volume and then convert back to polygon. You can see the difference. Okay, I prefer it this way, but I want to show you that you could use subdivide and it will be faster. Okay, so we have our smooth. Okay, let's call it smooth Voronoi. And now let's give some colors to it. Okay, before that, I'm going to increase these numbers maybe to 1200 points. The result. Of course, it takes more time to calculate everything. Now you can see the points are way too small. So our smooth is smoothing a lot our polygons. So let's see. So we have our piece. When we smooth it out, it really goes away. Let me maybe change the resolution of our voxels on the VDB from polygons. Let's check everything if we can see the pieces now. Okay, pretty cool. I can see maybe this is way wrong. Okay, pretty cool. Maybe we'll decrease the voxel size. In other words, increase the resolution. Let's see. Okay, pretty cool. They are more together now. I want maybe go back to smooth iterations. Hope I don't delete everything. See? And they are too round now. Go to. Okay, that looks cool. Let's see on frame 30 with a little bit of movement from our flow noise. Let's see how they look with different pieces. Okay, pretty cool, pretty cool. So now let's give colors to each piece. So let's go to our scatter. Okay, and before our scatter, let's use an attribute from map. Okay, so we are going, let me increase this so you can see a little bit better. So we are going to add an image to our grid. Okay, so let's pick up our grid. So I put my images on local images. Let's use this one. It's a square image. Okay, so we have our image. Okay, pretty cool, right? So now if I tag this to our scatter, okay, you will see that our points, so maybe if I turn my background to dark, you can see now that my points have color, right? Hope you can see this one. Okay, so now we are going to transfer those parameters to our pieces. If you see, if you go with our popnet or particles, you can see that our particles have the same color and will stay the same. That's why we are adding the attribute from up before the popnet, because if you add after the popnet, you can see the difference. The color will be always updating. Okay, so for example, this particle that maybe this particle that starts with pink, after a while is yellow, and at the end is red. Okay, because they are updating with the image. Okay, and we want the particle to have always the same color from the start to the end. Okay, so after a while you can see that we are destroying a little bit our image but that is our purpose. Okay, so our Voronoi, our pieces. Okay, now as I said, we need to transfer the color from the particles to the pieces. Okay, that is easy. Just use a transfer node, attribute transfer. Let me look for it. Here it is. So the first input is the geometry, and the second is the other geometry that we need to transfer the attribute. So in this one already has this. Okay, so in our points we want to transfer the color. Okay, don't need to transfer anything on the primitives. Okay, so now our pieces have a point attribute that is the color. Okay, I'm mentioning this because it is a point attribute, so in case if you are rendering this with Redshift, you just need to import the point attribute node and use that on render to color your pieces. Okay, and if I go to the first frame, you can see that is it has you can see the image, first image. Okay, that's pretty cool, right? So let me cache this system. Let's go file cache and do our magic and cache everything. So let's Voronoi cache. Okay, and let's save to disk, and I'll be right back with our cache system and the flipbook so we can see the animation. So be right back. Okay, so I've got everything cached, and I did a simple flipbook to see the result in real time. So here we have our Voronoi, pretty cool, this organic movement, right? And as you can see, our pieces are moving with the colors. Okay, so now you ask, why Docksip? Because this is deforming our image, and you said that we are going to form the image. So now if we press play, you can see this is deforming, but check this out. If you go to the last frame and reverse play, you can see that we have a forming image. We are random pieces, right? And at the end, they are forming our final artwork. So we just need to reverse this animation, and instead of going from 1 to 150, from the start to the end, we want to do the opposite. Okay, so let's check this out. So let's use a simple time shift. Okay, I do this with time shift. I guess there is other ways to do that, but I like to do it this way. So I'm pressing this to see the expression. So I want to use the frame end. Okay, this little expression gives us the length of our simulation. Okay, I'm using this instead of writing 150 because you can increase the size of your animation and this will be updated. Okay, you can see this is 150. So we want the number of maximum animation, or number of frames that our animation will have, and less our frame number. Okay, so on frame 1 we are on 149. So as you can see from the start, it is bug, so we want to be on 150, so let's add +1. Okay, so with this little expression you can see that on frame 1 we are on frame 150 from our cache, and if we go to the last frame to 150 we are on frame 1. Okay, on frame 90 we will be at 61. So this way, as you can see, we are starting with the artwork deformed, okay, and during the time we can see that our animation is being, our artwork is being formed. Okay, so this is one way of doing a generative art. Okay, the little tip and trick. So you kind of pick up your artwork, deform that, and reverse the animation, and voila, now you have generative art. So that's pretty cool, and I'm going to do, I don't need to do a flipbook, but because you already have, it's the same result, and we have our Voronoi pieces moving. Hope you enjoyed this combination with particles and Voronoi. Pretty cool to see this organic movement and see the artwork being formed. If you enjoyed this tutorial, don't forget to hit the subscribe and like button. Check our content, and if you enjoy, consider supporting us on Patreon or Jammy to keep doing these tutorials. Hope you enjoyed this tutorial, and don't forget to vote on next tutorial's theme on our Patreon page. Have a nice day and see you on the next one.